Now that we understand what it means for a function to be destructive, I want to make sure you also understand why this designation of destructive or not destructive matters, and when you want to use or create a function that's destructive versus using or creating a function that is non-destructive. So why do we even care? This designation is important to keep in mind because it sets mental expectations for the programmer who's using a function, which very oftentimes, especially these days, is going to be you. Eventually in industry, there will be other people that are using your functions, and being able to tell whether the function is destructive or not destructive helps them think through how they're going to use that function in their code. And so this is important for dealing with these kinds of questions. Does my function need to return a value if you're writing a function? Well, if you're modifying the input value, then whoever called your function can look at that modified input value to see what was modified. So you don't need to return a value. On the other hand, if you have a non-destructive function, you probably need to return a value, and whoever is calling your function, or if you're calling a function, you probably need to save that value, that return value, into a new variable, because the input value wasn't modified. A new value was created and returned. A super common question that you'll think about when you're working on code is, can I trust that this function call will not modify the list that I give it? Or actually, more broadly, are there any side effects to my arguments when I call this function? And for destructive functions, there are side effects. The side effect is that the input that was given to the function is changed, it's modified. And so the value that you passed into that function will be updated based on the execution of that function. Whereas for non-destructive functions, you can count on there not being any side effects, at least to the input values. The input values won't change. Maybe the function will return something new, or it'll print something out, or write to a file, but it won't modify the given values. In fact, if we had more time in this class, I would talk to you about this idea of preconditions and post-conditions, which is a way that we sometimes teach how you should reason about what a function does. You can write out preconditions, which are expectations, or okay, for example, I expect my list to have more than one item in it. I expect the input to my function to be a list with more than one item in it. For example, my example of having a to-do list where you need to cross something off. Your precondition would be that you expect to be given a list with at least one item on it. And then your postcondition for a destructive function would be that the given list has the first item removed. Whereas for a non-destructive function, the given list will not change. So that isn't in the postconditions. Fortunately, since we don't have time in this class, I won't talk about preconditions and postconditions. But that's something you can look up if you're curious to see how people reason about what their code does. The next question was, when should I write or use a destructive function? Because now you know whenever you write a function that takes a mutable input, you always have the option to mutate that value and therefore make your function destructive, or not mutate that value, should make the function non-destructive. The time to use a destructive function is when you want to update some mutable value, of course, that's by definition. But the important thing is that whoever calls your function does not need the previous value anymore. And that's because in a destructive function, you'll be modifying the given value. You'll be mutating it. So if the previous value is still needed, you should probably write your function to be non-destructive so that you return a new value with the modified changes and you leave the input value alone. And yeah, it's kind of written out here. You might ask, hey, why don't we always use non-destructive functions? Well, you might have noticed if we go back to our code up here, it was considerably slower for us to do a non-destructive append, because in a destructive append, all we did was add a new item to the end of the list. That's pretty quick. But here, before adding a new item to the end of the list, we had to copy over all of the existing items, which takes a lot of time. And also, if the list is really big, it could take up a lot of space. So unless you need to keep the original value intact, it is usually faster and more efficient, and uses less space to write a non-destructive function that just mutates the input value. So here's a little quiz question for you on that. Take a look at this code. This code reads in an image, obama.png, and then it'll call flip filter on the image and creates a result 1, which is that image flipped. Grayscale filter on the image, which creates result 2, which should be the original input image but made grayscale, and then blur filter given the image, which makes result 3, which should be the original input image but blurred. Do you think these filter functions, when you create them, should be destructive or non-destructive? Take a minute to think about it. Okay, they should be non-destructive. And that's because we keep reusing the original image. We don't want to have to keep reading in this original image every time. We read in this image and we want to get back a flipped version. We want to get back a grayscale version. We want to get back a blurred version. It's kind of interesting. The code would still run if you had these functions be destructive. But what you would find is that if flip filter given an image actually flipped the exact given image, if it didn't return a new image that was flipped, but flipped the original image, then when you would go on to execute the next line, this grayscale filter, you would find that the result of the grayscale filter would compound with the previous thing. So first we would flip the image, then we would make the flipped image grayscale, and then we would blur the grayscaled flipped image. And so each of these results would actually kind of stack upon the previous things, because you would be modifying, if this was destructive, you would be modifying the original image. Another good hint here that these filter functions are probably non-destructive is because we assign the return value to a result. Usually with destructive functions, you don't assign an output to anything because you don't need to return anything. The original input is modified. One more parting quiz question for today. Take a look at this function, this mystery function that takes in A and does something. What does this function do? And is this function destructive or non-destructive? Take a minute to think about it. You can pause the video. Okay, I'll give you the answer now. This function will return a new list, B, which is made up of the first 2 items in A, so index 0 and 1, and then the first 3 items in A appended together. So index 0, 1, 2. And this function is non-destructive because slicing creates a new list. So each of these slices creates a new list, and then we add those 2 new lists together and we return B. This original input that we gave, A, is left completely untouched. And so if I pull this up in Python Tutor, we can take a look together. We create a list of numbers here. And when we go to call our function, A is in the new frame, this variable A, which is the variable name that points to the list that was given as input, 2, 3, 5, 3, 7, 5, 11, 13. And now, when we go to execute line 4, this creates a new list, which is made up of 2 and 3, because that's A sliced through the second index, so 0 and 1. And then 2, 3, 5, which is A sliced through the third index, 2, 3, 5. So we get 2, 3, 2, 3, 5. Return B. And so when we return back, we now assign the return value to the variable nums_result right here. And now when we print these out, you can see the original list is untouched, and the new list is 2, 3, 2, 3, 5. So nums result. So these are 2 separate lists. So the function is indeed non-destructive. Now I'll show you a quick example, by the way. You can't just assume that if a function returns something, it's non-destructive. That's not always the case, because I could do in here, I could do a.pop 0, And if I run this code, whoops. Yeah, so if I run this code, you can see when our function gets called, the very first thing it does is it actually mutates the input list. So this list, you can see 235, 375, 11, 13. After we run execute line 4, it pops off the very first number. So there was a 2 there, and now it's gone. And then we create a new list. And we still return that list, and it's great, we have a result. But the nums after executing the function is now one number shorter. See, nums before had started with a 2, now it starts with a 3. And so this would be an example of a function that is destructive because it modifies the input list. And on that note, we'll wrap up for today, and I will see you in class. Bye.